It's my favorite time of the day. Love standing between developers and their beer. But on the plus side, means you're a dedicated bunch. You came here to actually listen to the talk, not just count minutes until you can go out. So thank you, appreciate it. Thanks for the introduction. So I'm going to talk about Node.js. How many of you actually programming in Node.js? It's popular, right? At least everybody's talking about it. And so we're going to talk about a little bit about architecture. Really about things that you shouldn't do with Node.js, I guess. A couple of gotchas to keep in mind when you develop, right? Denial of service attacks. Going to discuss their cryptography and use of random. And ways to do SQL injection, even though typical Node.js applications use NoSQL as a backend, MongoDB or similar database. You can still do SQL injection-like attacks on those. All right? So, Node.js. Node.js is an event-driven framework. Right? You have an event queue, a single-threaded event queue. It's being processed by an event loop. And tasks are usually kind of farmed out to worker threads, right? So if it's a file system, something with I/O, or if it's database, network task, they're being run by separate threads with the callbacks going back to the event queue. All right, so it's sort of pretty simple, but here's putting it in a little bit of a human terms here. Think about it, right? The fast food ordering system where a guy takes your order and kind of hands off tickets back to somebody who actually fills them, right? It's a very efficient system because somebody's always available to take your order. There's no guarantee that you'll get your order fast, right? The system can still be busy, but at least you feel better because you've been served. All right, any questions, I guess? No. So, what's good and what's not so good about this architecture? And good is that I/O-intensive applications are actually responsive, right? There's always something to that process's user input, user request. It's very good for database queries. Queries can be executed in parallel, right? And that's pretty good for UI-intensive tasks because when there's a lot of interaction with users, a user feels that the system is responsive. Right, so suits web apps very well. Not so good for complex business logic apps and CPU-intensive apps because of the single-threaded nature of the framework. Right? You tie up that order taker. Right? If that order taker has to, I don't know, go get change for you, or your credit card is declined, or something like that, you see people lining up behind you. So that's not a very good experience. And that's actually the first thing you learn when you start programming in Node.js. It's easy to create a system that's really susceptible to denial of service attacks. All right, so here's a little app that calculates a sum, right, of numbers from 1 to p. Right? And I'll show you what kind of effect it has on the system if p is sufficiently large. So I've got a few links here. So, if we do it with 5, right? It's a quick operation, 1, 2, 3, 4, 5, 6, 7, whatever it is. The sum of 15, system returns pretty quickly. All right, so why don't we do it with 5, well, whatever it is. I don't even know what the number is. Big number. See, it's calculate. But the thing about it is that all other threads, all other user threads are also hung, waiting for that long one to come back. So even our quick and easy calculation from 1 to 5 cannot return until the longer operation is complete. So that's not something you would want your users to experience, right? You don't want one user session to hijack the entire application. It will eventually finish. So I think in my test it took about 40 seconds here. So crafting, figuring out what input makes your application run for a while can be used to do pretty effective denial of service attack on the app. Maybe I need a better processor. My laptop looks like. It's by the way, it's chugging along. Yeah, Node is here, single-threaded, using 1 core. Anyway, not going to wait for it. Let's go back to the presentation. So keep that in mind, right? No long-running application logic, things like that. And interesting fact about did I skip some? About Node.js that you probably already know is that it runs a version of V8, which is Google's JavaScript engine. All right, so it, instead of running it in the browser, runs it back on the server. V8 has a known weakness, and we'll talk about it in a second. But this actual code snippet is from a real code, right, from an open source project. And it's used to generate passwords for new users. So what's wrong with it? Can anybody tell me? MD5 is bad, right? Why is it bad?
Because it's weak.
Easy to break. But you know what? We're generating a new password. Somebody's going to change it, right? So it's really we're not using it to encrypt communication, which is generating a new password, which is going to be a string of meaningless numbers and letters. So MD5 in general is bad, but that's not why it is bad here. Okay?
And also it is using math.rand, which is a secure RAM.
Right, so math.random is not secure. That's a more, it's a worse problem here. So, yeah, it's a pseudo-random number generator, but it's not really random. And it's actually known to be weak PRNG. So the way it works is that in V8, they use a system call, rand or something like that, to generate a seed. And from there, they have this sequence of states. Part of the state variable, it's a long number, is used as that pseudo-random number, and the other part is used to generate the next seed, next state. Sorry. Okay, so it continues. Now, I imagine everybody will get a copy of my presentation. There's a link to Amit Klein's research. few years old research, but Amit actually figured out that by knowing three consecutive random numbers, we can predict all future random numbers. All we need is just three consecutive random numbers in anywhere. Right? So how would we attack this this particular system? Right? We can actually generate three passwords that will give us three MD5 hashed random numbers. MD5 hash is somewhat easy to reverse, right? It's computationally not very expensive to reverse it. And so that will give us three consecutive random numbers. And from there, we can generate fourth, fifth, sixth, etc. And actually see what the future new user passwords will be. We'll go through the attack in a few seconds, but that actually is a known issue. It's been known issue in V8 since, I don't know, 2009, 2010. And it's not a big issue in browsers, because in browsers, each tab runs in its own process and has its own chain of state variables, its own chain of random numbers. So guessing that sequence will only compromise your own tab, which is not exactly very interesting, right? But remember that Node.js runs one copy of V8 for everyone. And so there it becomes an issue. Okay. So what we're going to do, and we're going to actually demo how easy it is. We register one user, register second user, register third user, reverse MD5. Yeah, cool animations, right? I have to give it to my marketing folks. They took an engineer's presentation and turned it into something I can actually walk you through. All right, and so reversing MD5s will give us three random numbers. From there, we will generate the fourth and be able to predict passwords. So for that purpose, I'm going to go to like a very secure website. You know it's secure, right? Because it has a lock, big picture of a lock on it. So it's secure, and we're going to register users. User one, register. So suppose we get an email, welcome user one, this is your completely unbreakable password. Right? Then we're going to feed that completely unbreakable password into an MD5 decoder that we built for this purpose. It's one big rainbow table, lookup table, brute force, reverse engineering. It's a big table, but it really is not very difficult to build or to use. There it is. This is the first random number. We're going to feed it into a very handy calculator. I'm going to go back, register user 2. Repeat, rinse, repeat. Gives us random number 2. Okay? And so 3 consecutive random numbers. We're going to get the 4th consecutive random number and an MD5 hash of it. That's our password. There's quite a bit of calculation involved.
What happens if someone generates a random password?
You try again. Yeah. Since you can really register.
You hope that the website is not too popular.
Yeah, my secure website is probably not too popular, but remember, you don't really have to type these in, right? You can just submit them through a script, maybe even in a single request. 2 a.m. in the morning, right? It's crunching. Story of my life. Demos, live demos never go smoothly, right?
How do you know that nobody has generated a password between that? How do you know if this is successful or not?
Oh, so this can be used to generate new users. So it actually is probably more interesting is to use it to reset somebody else's password, right? So I enter 3 fake emails, my own emails, get 3 random numbers. Should have come back by now. And then I go to reset yours, right? And even though I don't get the email with your new password, I know it. And so I try to log in. Right? Yeah. No matter how you try, how many times you try before the presentation, right? Anyway, trust me, it works. Let's see if it comes back in a few more minutes. But maybe what's that?
Is your doc still running?
No, that one completed. Yeah. So. Ah, darn. You trust me, right? You trust. This is a security conference. You'll trust me. But yeah, it works actually. And so we did a version of this talk at AppSec. Not this talk, but slightly different talk. But use that.
This was just a randomizer in V8. But
yeah, I mean it's math.random. And their implementation of math.random in V8.
in just V8.
In V8, yeah. So it's probably very similar to other implementations of math.random. So you probably shouldn't use it, or at least shouldn't use it in this easy to break manner, right? At least hash it with something more than MD5, I guess. But I guess the defense. Is maybe use authorization tokens instead of just generating new passwords, things like that. But you actually have to get that email with a new token as opposed to be able to guess the password. All right, MongoDB, right? And JSON-based SQL injections, I guess. So majority of Node.js apps actually use MongoDBs or a similar database as a backend. It's a document-oriented database. It stores objects, not your traditional tables and rows, right? So there's no native SQL commands there. And you can actually do operations on it using JSON. It's very easy to adapt for typical web app development. Yeah, a lot of objects are stored as can be represented well in JSON format, and they're natively stored by the database. So, you operate on the database using just plain JSON structures, right? You can actually store very dissimilar objects in a database. You don't have to try to fit everything into a neat table, key, etc. architecture. You can search database using JSON structures, right? So you can specify partial match. You can specify operations on it as well. So, regular SQL injection is not possible because there's no SQL, right? So I hope everybody here understands that this is not a good way to do SQL, right? Now, in JSON format, something like that would look very similar, right? You get password from the user, you get name from the user, username from the user, and you do find. Now, the problem with it is the JSON actually accepts operations, right? Greater than or less than. So I can do something like this and say, give me all usernames with username greater than A and password greater than A. It's just about any string is greater than A, right? So let me show you a little bit. Is it still running? No, it's not running. Going back. It's done finally. So this is the state variable, the next state variable. This is the password. So if I go back to my user and try to register another user, so it starts with 9B64, ends with E6DC. Oh. Yeah, maybe we didn't do the right numbers here. If we have time, I'll do private showing. Interesting. I have another secure site, right? Here's the secure site. And let's try to log in as admin. OK, so it's admin. But suppose I don't really know it. And I'm going to do something like A and A. No, that doesn't work. System doesn't let me in. But if I do something like this, where user is greater than A and password is greater than A, okay, come on in, you're in, right? And so not checking for kind of disallowed characters in your username, user password in your query can still lead to bad results. Right, so we just did that. Now, a common defense against this type of attack is to go find that username and then compare passwords, right, in a separate operation. So well, yeah, that might work a little bit. However, even the first line there in find, that can be attacked using regex. So if I supply a really, really, really long regex string for it, well, your system's going to be tied up forever. So let me show you how that works. It actually takes a while to paste. Oh. That just kill it. Should we wait or should we kill it? What do you say? Kill it? Wait. Kill it? Wait. There we go. All right. So, well, it ties up the system, but the idea is that if you remember, Node.js is a single-threaded app, right? So if I tie up one session with a very long and very nasty regex, everybody else will be waiting for it to return. So I guess a little bit of a random advice from Einstein in the end. So that's all I actually had to show. Now that it's late in the afternoon, so probably have a few minutes for a Q&A. Maybe I'll redo the once my system actually comes back. Redo the other demo. But remember that Node.js is a very powerful thing, just not don't put business logic into the thread, right? And do validate input, no matter what the underlying system is, framework is. You always validate user input. Let's see. I have to show it. It has to work. Register. There's my system completely hosed now. No, it's okay. Right. Let's see. No, it's not over yet. Anyway, that's really what I had to show you guys. I hope that doesn't scare you away from using Node.js in the future. Right. Thanks for coming by. Welcome to stick around and ask questions.
So is there a secure random in Node.js? You can't use the method. What's the solution?
There's no secure random in Node.js, right? You can either find a library that does it.
Are there any libraries that actually do a good job of it?
Or you can use a native code, randas, instead of rand, just regular rand, srand. I guess depends on that. Or hash it with something that's harder to break, right? Here's finally it's back. So 3653. Yay! It does work. Right? Wasn't some black magic with predefined values, but yeah, I mean it's an interesting attack that kind of comes to as a surprise to a lot of people that, oh, but you don't know my email, right? How come you guessed my password? Oh, I don't really need to read your email to guess your password. I can do it. It's an interesting fact that the vulnerability has been known, and there's actually an open bug on V8, and the V8 I forgot what they use, but you can go and read the whole thread that basically said one fix because it's really not applicable to the browser. So in the presentation, there will be links to original research that talks about vulnerabilities in V8. There's going to be a link to MongoDB exploits. So play with it, see how easy it is to break. I guess manipulating JSON is new for a lot of us. I think most developers have come to realization that using dynamic SQL queries is no longer the right approach, and we use parameterized queries, etc. But working with JSON is new. It was very new to me, and when we played with this with the queries, it was very interesting to see what's a different type of attacks can be developed on JSON, on NoSQL.
So also, what's the fix to the JSON injection that the greater than or less?
Input validation, right? There's no way a user needs to have GT, semicolon GT, I guess, in it. It's always input validation, right? There's also, I think, maybe some newer drivers that have that built in, encoding built in, but don't keep that in mind. Don't trust secure sites either, even though they have a lock, picture of a lock. All right, thanks. Thanks, everybody.